Recording, cool. All right. It's going to give maybe 1 or 2 minutes just before class. Okay, cool. All right. So how is everyone doing right now? It's been a little bit since the last Java class, so yeah, I just want to see how everyone's doing right now. H5. All right. Good to hear. Good to hear. All right. So next in the Java series that we're going to be doing here, just in case people don't know me, I'm a new teacher with the Code the Universe. I am a third-year college student. I've done Java for about 2 years, and I just totally enjoy the language. So getting started, the subject today is going to be putting the object in object-oriented programming, which Java is all about. Now, we were introduced to objects first with the string class. As you were taught in the last few lectures, we have stuff like integers, chars, booleans, stuff like that. These are what Java considers as primitives. These are like base data types that we use to hold basic information like numbers. For chars, it would be letters, and for booleans, it's either true or false. What differentiates a string from primitives is that we consider this as an object. An object being a more complex data type in which holds more information per se. So let's just get rid of these here, and then we'll have our test string here, which is going to be equal to a double quotes, going to be empty. The one thing that differentiates strings as an object from other objects is that we can initialize it with something other than, we'll say, a new string, such like this. What this new keyword does is that it allocates a space in memory for an object to be designated to. So given let's just say we have the idea of, let's just say that memory is like a bunch of different boxes. And these names that we designate for each object are a label on the box, and what we store inside each box is our information. This, for Java, it's not necessarily important to understand, or it's not as important as other languages out there. But for Java, to get the general idea of what memory is supposed to do is pretty important in my opinion. But yeah, everything. I apologize. I'm a little bit nervous for teaching, but okay. Talking about objects more. The point of objects within Java is to describe how to manipulate information so that we're able to gather more information or just manipulate certain things. Like say we could make a printer object out of just code, or describe how a printer acts, what it is, certain properties of it. And that's what classes are supposed to do in Java. They give definition to things that we can describe using code. Now, a class has two different key parts to it. We have our fields, which are pretty much just stuff like we've been already describing, like integers, chars, or other custom-made objects that we put into a printer object that we need to store. So given a printer, some stuff that I think is important for a printer to have is stuff like how much black ink it has, and how much of the different types of ink it has, and then a quantity to say how much paper it contains. This sort of stuff needs to be kept track of inside a printer object. And then the next thing that I want to talk about after I get these fields taken care of is the methods. What we give to a class to give it some functionality, something to do, or cyan rather. So the first type of method, which is rather important for initializing objects that I want to talk about, is a constructor. What a constructor is supposed to do is, upon initialization of a printer object, we run some code when starting up a new printer object. We run some code just so we could maybe initialize our quantities here, or do some other stuff that we need in order to use a printer object. But for here, we just want to say that we have a quantity that we want, or a tank quantity for every single ink tank in a given printer, and initialize the paper quantity and initialize the paper quantity to say that we're giving a certain number of pages to a printer to print out stuff on said paper. And how we do that is using these parentheses right here, and suggest that we take in values that a user will specify to initialize all these quantities. So that will specify an energy, rather say that's a double tank size, and then an number of papers, or number of sheets, we'll call it, to initialize how much paper we're initially given to this printer. So that we'll say, so that inside this method we will specify that we want to give the quality that we're taking in to the paper quantity that we have initialized already. And then for the tank size is going to act like our initial refill point for whenever we have to refill the ink quality or ink quantities after we're out of ink, we'll say. So that we'll say that tank is equal to tank size, as well as the quantity of black in the printer already is also equal to tank size, as well as the magenta, yellow, and cyan quantities. And we just can copy and paste some code right here. All right, and then that is essentially the constructor. If we take a look at what we're doing, whenever we initialize a new printer, we'll do that in the main in just a second. We're taking in a double tank size and a number of sheets of type int, and then we're initializing these quantities up here to these given numbers, so that we can start doing stuff with these numbers. Say that we want to print something out, and for this method, we'll take in a string, but for the data type, we will be returning void. Void giving returning nothing from the method and just saying that we want to take in a string text, and that will say that we want to print this out, but that we also want to use these quantities up here. So that we'll say something like I'll just keep it like that for now, or just keep it like that. We'll say that we'll is so that we'll take 1 unit of ink, we'll say, from the black quantity, as well as for magenta, yellow, and cyan, because we want to be using everything in a print right here. And then cyan. And then we'll say that we used up 1 sheet of paper for, actually I don't want int right there. We'll use up 1 sheet of paper to just say that we use 1 sheet of paper up. And from last class, I believe you learned about the decrement operator, which is essentially just the opposite of the increment operator as specified right here. This suggesting that we're taking 1 from the paper quantity. This suggesting that we add 1 to the paper quantity. But for this case, we want to use up 1 sheet of paper, and then we want to print out the text. But we also want to add some conditions to this code. saying stuff like if the paper quantity is not equal to 0, then we are able to print out everything. Then we are able to take out some magenta, take out some color, and then take out a piece of paper, and then write down whatever we want on said piece of paper. Now we can also do methods like print in only black and white, even though for this console we can only print out in black and white. But there are ways to actually print out in color that I can talk about if anyone wants. Okay, no sort of indent there. But we can also specify that if paper quantity is 0, then we will take, we'll say 2 or 2.5, some quantity greater than 1, because we're using a lot more ink, a lot more black ink than in a regular print. And then we'll take 1 from the paper quantity and then print out whatever we want on this said piece of paper. Double minus, and then system.out.println the text. Now, whenever we use up our paper, we're probably going to need to refill at some point. So another action that we can add to a printer object is that we could say that we want to refill the paper quantity with a given number of sheets. So we can specify that we want a void method saying refill paper, so that we can add some paper to the paper quantity by saying plus equals. We will specify that we want to take in a value in the parameters, so that int refill, we'll call it, so that we add more paper to our given quantity. So for now, we'll stick with these sorts of methods and then return to main. Now we can specify that we want to create a printer object by just saying, we'll say just printer for now. So what I'm doing here is that I am specifying that I want a printer object from this printer.java file and gave it the name printer. And then on this end of the equals, we're specifying new, which is essentially allocating some memory so that to give to our printer right here. And we'll call this printer 1. And then this part is the constructor saying or initializing it as a printer. Now back to our constructor from the printer Java file, we're specifying that we want a tank size or maximum tank size for each of our ink tanks, and that we want a number of sheets that we already put into the printer. So go ahead, do that here. We want to say that our printer size is about 200 arbitrary units. We'll just give it ounces per se, and then we'll give it 50 sheets of paper. And then we can initialize another object. We'll give it printer2, and also specify another printer object using the new keyword and a printer constructor. And we'll say that this is 100 ounces, and we will give this 15 sheets of paper. Now these are what Java does is that we allocate two different parts of memory to specify that these are different objects within the Java within our memory and our public main class, so that we could say printer1 dot print, which is a method where we specify what we want to print using a string. Now that we remember that strings can be initialized using quotation marks or double quotes, and that we want to say text field, text filed, fantastic, text field. And then we can do the same thing for printer2, and also say the same thing. But what happens is we're using each printer object to print out the same thing. Now we're not going to be able to see the internal workings of, or we're not going to be able to see what or how the main class interacts with each object, unless we have what are known as getters. Now, the two types of common methods that are pretty well used are what are known as getters and setters. Now, getters primarily are used to tell us what happens within, or tell us what is stored inside these values. Now we'll say that we have a getter for the black quantity, and that we want to return it so that we know how much is left. So that we'll say public. We will get to what are known as access modifiers soon enough, but we want to specify, why does Oracle hate us? Good question. People will be asking that for centuries. Okay, but we'll be specifying that we want to return an int. Actually, no, a double for the black quantity. A double for, double for black quantity. And that we'll say that our method is called get black ink. We'll have no parameters in here because we don't want to take anything in. We just want to return the black quantity. Not sure why. Okay. All right, so now that we have a value that we can now get from our objects, we can talk to the console and say that we want to print out the quantity of black ink for printer1. Get black ink, as well as printer2. Well, we'll just copy paste that. And also McDory, I don't know how to pronounce your name, but what makes you say that? What makes you ask about Oracle? And then after we print out text field, we'll want to see what happens to the black quantity inside each printer before and after we print something out. So we'll just have this run some code because Java is closed source and it gets worse year by year. You might, okay, so I have some sort of issue here. Yes, I didn't have a semicolon. Always remember your semicolons. I believe that was probably my only issue there. Never mind. Okay, so it was probably a misspelling somewhere. Return dump. I apologize for this. I am not quite sure. Maybe make it public. What declared is black quant. You're very true there. I appreciate that. Quantity and then quantity. Okay, I think that should be good. Simple paper and okay, probably another, yeah, another spelling issue. Okay, it gives me an error. It says that a period is not recognized. Error at printer one print text field. You're probably gonna have to give yeah, okay, so some screenshots here. Let me take a look. Screenshot your printer Java file, and then we'll go from there. But as we can see in the console, before we do anything with the like printing anything out, we can see that printer one has print black ink quantity was initialized to 200 ounces, and that printer two's was also initialized to 100 ounces. And then after we print out some words, we get those quantities reduced by one. Never mind, I did add method as capital. Yeah, Java is very case sensitive there. But let's say that we want to print out a large sum of papers. We'll say that int I is equal to 0. I is less than, we'll say 100 for this example because we'll be using printer2. Printer2 dot print. Actually, no, this is for how many sheets of paper we'll be having. So initialize to less than 15, and then I++ to increment the I integer, and then we'll just say that we want to print out just I. And then we will also specify back in print that if we run out of paper, that we want to do something else. So that we'll specify another statement where we'll have system. I just came, so tell me what about you did before. Okay, so Yoshi, what we're doing right now is talking about objects within Java, which is like the meat and potatoes, I'd say, about learning how to do Java. So object-oriented programming is about initializing objects, and there's a few things that we do to do that. We have these fields up here, which essentially are just any sort of data type that either Java gives to us or that you can create that an object has to store. That is the first part of it. And then we have methods down here, but to separate the constructor from normal methods, our normal methods operate. We started doing class. Okay, so we have our normal methods down here that operate after we initialize our object. How we initialize our object is through something called the constructor, which is right here, which has the same name as your class. What the constructor does is initialize or do some code before you do any sort of methods, and initialize any sort of data types you may have up here that were previously just not initialized up here, so that afterwards you can use stuff like the methods that we have here, or get the values from these fields up here. So back to the example, let's say that given this code that we've already done, we're saying that we want to print out. We're saying that we want to print out 15 more sheets of paper with numbers on them. But also, we have to specify that. Actually, is it error? That once we run out of paper, we want to give some sort of feedback that says that we're out of paper. And then we'll probably do the same thing down here, since they both take from the printer quantity, or paper quantity, my bad. And then we'll run this code right here. Oh, that's right, because I'm taking in a string. Okay, so the easiest way that you can input integer values as a string is using the string.valueOf method, and then inputting. You can input integers or doubles or any sort of like numeric data type in there. And that was an accidental click by me, but okay, yeah. So right here, we're printing out that we have the numbers 0 through 13, and then once we hit number 14, it says that we run out of paper, and that is because we only initialized our printer 2 to be with 15 sheets of paper, and we've already taken out one. So that's once this value hits 14, it says that we run out of paper because we used all 14 sheets remaining to print out 0 through 14. Now we can look at we can also take a getter of the paper value so that we see that the paper value within printer 2 does not affect in any shape or form the paper quantities of printer 1. So that we want to output or return the paper quantity that we have left, and then always remember semicolons. And then back up here, we'll also specify that system.out.println for printer 2 first, get paper with parentheses specifying that it is indeed a method. And then we'll also print out the paper quantity for printer 1 to show that we still have, I think, 49 pieces of paper left in printer 1. Yeah, 49, and then 0 for printer 2. And then we can just say that, let's say we want to give some more paper to printer 2, just so we refill it. We can specify refill paper, and then if we remember from our refill paper method that we want to take in an integer for the amount of sheets of paper that we want to give it. We'll just give it 200 because why not give printers 200 pieces of paper so you just don't run out as easily. And then we'll actually just copy paste some code. And that will show that we refilled our paper quantity to say that we have 200 sheets in printer 2. All right, so the next thing that I did want to talk about, if there were no questions about this sort of stuff, is about access modifiers for Java, which are also, now these are also keywords in Java that you've seen either public, you maybe have seen private. In common practice, it is good to say that we keep our fields up here private. It's just a security reason so that we don't accidentally or that no one maliciously can access these sorts of quantities without looking into the Java or printer.java file. Now, what access modifiers are supposed to do, we'll just go back to main so that I can just talk about this stuff. Now we have 4 different modifiers here. The most common being public and private, but we also have, we'll just say blank, because you can just leave this as just a class. And then we'll have protected. What is the difference between access specifiers and modifiers? Difference between specifiers and modifiers. I've actually only heard of modifiers. Protected. I will have to actually see what specifiers are. Specifiers. Okay. So we'll take these one at a time, giving them some reasonable definition. Control. Yep. Let's do that. Public is what you'd use for your classes for each file. Access modifiers. Access specifiers, good as access you provide to your code in Java, whether other classes can access or not. Access modifiers provide both access specifiers for creating access to your Java code for other classes. Okay, so I'll have to read up on that after this. But to get the basic definitions down for these access specifiers, I guess. I'm just going to call them modifiers for now. But public is your most commonly used one, saying that this can be accessed from pretty much anywhere inside just like your general directory of where you do your Java code. So we'll say that can be accessed from anywhere. And that will get into packages like this example package, which I don't have a file in, but we'll create a file for that in just a second to explain either blank or protected. Not so much. Protected isn't going to be an interesting one. But for private methods and private anything is besides classes can only be accessed within just the file itself. So that going back to our fields right here, these sorts of values can only be accessed within the printer file itself. So that's any methods that we specify inside the printer, or if we have, let's say we'll just say another class right here. This also can access these private variables because it is within the file itself, the printer.java file. And a term that is commonly used for this is called file scope, meaning that it is only accessible within the file itself. Now, having just a no modifier, just keeping it blank, means that it'll be accessed by any class within the package. And also protected does this with an asterisk. If anyone wants to look up how superclasses work, you can definitely do that as extra credit per se, or some just extra warning if you want to. But we will say that we have a Java file just called box inside our example package. Now we'll say that we'll just give it some standard stuff. Public class box, and we'll and then from here we can say that, or we can just give it some example method, void. It's called test method. Fantastic spelling. Just give it a test method, and that we want to specify a printer class within here. Let's give it this printer3, initialize it with a printer constructor, and that's give it a double 100. Now this is in Java is legal to do, but if we were to say remove public access and just give it a blank, or give it no modifier, this becomes an issue. Because if we let's say we there's the main. Let's say we initialize a box. Initialize a box right here, and then say that we want to run the test method. Okay, that was strange. Thought that was supposed to give an error. Huh. So I will be honest, definitely don't know what happened there. I was supposed to, I'm pretty sure I was supposed to give at least some sort of issue with an access issue, but my knowledge with Replit is a little bit font bigger because I can't see. Fair enough. I will go ahead and do that. But my experience with Replit is a little basic. I do work in IntelliJ a lot, but generally IntelliJ, you will get access modifier exceptions if you try to run. Let's say you have some sort of class within a package, and then you try to access something outside that package with a modifier that's not public, or in some cases is not protected. You will get access modifier issues. But we could actually try giving this, and we'll say that this, or we could just say that we want to give this method, we'll give this method a private access. Now that gives an issue because our access modifier is private. Rather, it's just not public. Hmm. Okay, so that is interesting. That that no modifier still runs this fine. Okay, that is interesting. But are there any questions about anything that I've gone over? Okay, looking like no questions. Okay, so one thing that I did want to talk about uh, when using constructors is, let's say that I wanted to say that this double is also called tank, and that we'll just say that we are initializing these all to the tank variable right here. Now the issue with this is that when we're trying to initialize a field of the same name as a parameter that we're taking in, Java will always think that we're trying to initialize or trying to assign the parameter tank as the parameter tank again, which in lots of IDEs it will just be marked as useless code. So the way that Java gets around this is specifying the keyword this. Now this keyword is used to specify that we want the fields tank rather than the parameter tank, so that we initialize the field to the parameter. Be, the this keyword is used to specify uh, the object, the current object that we're initializing, so that when we start initializing stuff, say our printer 1 and 2, the this keyword always specifies to whichever one we're trying to initialize. So when we're trying to initialize printer 1, this is sort of a reference to printer 1, just as so that you can specify printer 1's fields right here, like the tank, the black, all the color inks, its paper quantity, yeah, stuff like that. Adding semicolons where I don't need to. Oh, something happened there. I guess it's just saving. Failing to connect. Interesting. Okay, so all right, we're back. Are there any final sorts of questions that anyone has? All right, so no questions. This is pretty much all I had for uh, today's lesson about the basics of object-oriented programming, talking about fields, how they're usually pretty much privately accessed, but if we specify getters and setters, then we can. Oh, I should probably talk about setters real quick. Okay, so we'll say that this is not the best example for it because we already have stuff like refill paper. But say that whenever we want to set a quantity for any sort of any sort of field that we have, we would use simple setters. I'll just get rid of the test there. We'll say we want to set the magenta quantity with a certain double value. What setters are pretty much used for is just setting the value to something different. Like we could specify that in the constructor that our magenta is the size size of the tank, but we could also but what setters do is just allow us to do that or control that more without having to reinitialize a new constructor, so that we can just specify that we want the magenta to have a different quantity from the other colors, and then we'll give this a getter as well, magenta magenta, so that in our main, if we just comment that out, reinitialize everything, or at least our printer 1 and 2, and then recomment out everything. We can say that we want to set the magenta quantity to something lower than the other ones for some reason, so that we can say later down the line just get the magenta quantity and then just use that information however we want. So if there are no final questions, that is pretty much all I had for the lesson today. This